No.
All right, so we're looking at ellipses today. You've seen this in Algebra 2, so again, a lot of it will be review. Basically, we're just looking at equations of an ellipse. Can you pick out the important pieces of an ellipse? Can you modify the equation to look like it should to graph it? If I give you information about the graph, can you write the equation? Things like that, okay? So here is an ellipse. Don't really have to focus. This is the formal definition. We don't really need to focus on this. But an ellipse is a set of all points in a plane such that the sum of the distance from the two fixed points, the foci, these two things, is constant. So in other words, if I pick a point anywhere on this graph and I look at the sum of the distance from the focus out to that point back to the other focus, that total length between the two would stay constant the whole way around this thing. So in other words, if at this point I have a total distance from here to here to here is 10, then that's going to be the same thing like over here, that the total distance from the focus out to the other focus is still 10, right? That's the formal definition. The main thing that you guys need to be able to do is understand these vocabulary terms in here. So the vertices are the 2 points at the ends of the long part of the oval. Okay? The foci are going to be those 2 points so that that distance remains constant. I'll show you the formula that we'll use for that on the next slide. But the foci are going to be right in somewhere from the vertices on the major axis, and the major axis is always the longest axis, right? This is called the minor axis, and the minor axis doesn't have any vertices, it doesn't have any foci, it just has minor axis endpoints, and that's it. And then the center, of course, is right smack dab in the center.
So just to make sure the major axis is always on the longest one.
The major axis is always, always, always on the longest. That might be vertical, but yeah, it's always on the longest. Yep.
Is the do the axes go all the way across, or do they just go from the edge of the circle to the center?
The major axis is considered to go all the way across.
Okay.
So if I tell you the length of the major axis is 10, then this distance is 5.
Okay.
Give you guys a second to copy that down. Okay. So we have two different situations to consider. Like I said, you can either have a horizontal major axis or you can have a vertical major axis, right? So here's when you have a horizontal major axis. Some things to note. The distance of half of the major axis is always going to be considered to be A. Half of the major axis. So whatever your longest axis is, where your vertices and your foci fall on, half of that distance is going to be A, from the center out to a vertex. The distance of B is from the center out to one of the endpoints of your minor axis. So in other words, half of your minor axis's length. And the distance of C is the center out to a foci, or a focus, I guess, if I'm talking about 1. Notice that the relationship between all of these things looks like Pythagorean theorem, but what's the difference? Minus sign, right? And it should always be a squared minus b squared, because a squared should always be bigger than b, since I'm telling you a is half of the major axis and b is half of the minor axis, right? The other thing to pay attention to, the way that you guys are going to know whether or not it's a vertical or horizontal major axis is you're going to look at which term is your A term. Remember, should A always be bigger than B?
Yes.
Yes. So A squared should also always be bigger than B squared, right? So you're looking at your two denominators, and whichever denominator is bigger tells you which value is A and which value is B, right? Whichever variable your bigger denominator is under tells you which axis is your horizontal, or which axis is your major axis. So in other words, we're assuming that A, my bigger number, is underneath X, which tells me that I should have a horizontal major axis with A being the distance, right? So then the only thing that changes in the equation anyway for vertical is notice that A is now underneath the y term, right? But it still is the distance of the, half the distance of the major axis is still A, half the distance of the minor axis is still B, and the distance out to a focus is still C. It's just that it is now vertical for the major axis and the focus. Still has this relationship, right? What's the other thing that you notice about this equation? What is it always, always, always equal to? 1. If it is not equal to 1 when you get it, you need to make it be equal to 1. Okay? And we'll look at how we do that. But that is also a key point, is that it has to be equal to 1 in order for you to say things about these two pieces. So when you get your equation, how are you going to determine whether it's horizontal or vertical, major axis? See which one A is. How do you know which one A is?
The bigger.
The bigger of the two denominators will tell you which one has A, and then you look at which variable is in the same fraction. And that tells you if it's x, then it's horizontal. If it's y, then it's vertical, right? You should also know from the equation what b is, right? So automatically you should know what a is and what b is. They're just the square roots of both of those denominators, because that's a squared, b squared, right? And then you can find c squared by finding this. So all in that, you're going to be able to plot your endpoints of major and minor axes, and you're also going to be able to plot the foci, right? And then that's enough to give you the shape. Got it? Okay. So let's first match our graphs. Notice, just like last time, I've given you 5 equations, only 4 graphs, right? So let's look for the key characteristics. Here, what's the very first thing that you're looking for in your equation? You're looking for your bigger denominator to be underneath the x term because I have a horizontal major axis, right? Okay, so that would be like this one might work, right? Or D might work, okay? How do I know? They have the same exact denominators, right? So how am I going to tell which one is which? What the center is, right? So this guy should have a center at -1, -1. Is that where my center is over here? No. -1, -1 is down here, right? So I want -1, +1. That's this one, right? So I know that that first graph is going to be D. Done with that one, right? Okay, now what that means by process of elimination, this one should be A. But let's check it. Is my center at -1, -1? Yep. So that means that this one I can already do is my A graph, right? So now the other two have to be vertical, which are any of the remaining ones. Notice that the 416 is constant the whole way through, right? So again, we're just going to be looking at our centers for this, right? So this center should be at -1, +1, so I should be seeing x +1, y -1, right? Where do you see that? C. So that means that this graph is C. And now my last one has to be either B or E. Which one is it? It's E because I want my center to be at +1, +1, which means I need -1, -1, right? So this one is E, and we're done. So that should help you kind of get an idea of what you're looking for in your graphs, right? In general speaking. We didn't really look at A and B values yet, but that at least gives you the idea with the horizontal and vertical. Okay. Oh, there we go. All right. So now we want to find the vertices and the foci of the ellipse with the given equation and then draw the graph. Okay. So is this equation in good form right now? No. I need this side to be equal to, how can I make that be equal to 1? Divide by itself, right? So if I divide that piece by 48, then I need to divide everything else by 48, right? Okay, so how many times does 3 go into 48? Yep, 16 times. So we get x minus 5 squared. She sounded a little unsure about that. 16. How many times does 4 go into 48? 12 times. So that's going to be y squared over 12 equals 1. And now I'm good to go. Okay. In order for me to find my vertices, my foci, and be able to draw my graph correctly, I need to know my a, b, and my c values, right? What is your a value? No. 4. Square root of, so your a value is the square root of the biggest denominator, right? So this, it tells you what a is under, but a is the square root of that. So 4. B, which is 2 root 3. Good. How do I find C? Yep, so C is going to equal, and I'm just going to go ahead and do the square root version, okay? So square root of a squared, which is b squared, which is 12. Yep, so you don't have to re-square those values because you already know that this is a squared and b squared, right? Oh, thank you, yes. Oh, that was a way bigger eraser than I wanted it to be. 16 minus 12, good. And so that's going to be the square root of 4, which is 2. So this is enough information for me to now say, where is my center? First of all, that's going to help me. I really need to know where my center is before I start this, right? So my center is at what point? 5, 0. Very good. Okay, I'm going to plot this right now so that we can kind of be looking at it. So here's the point 5, 0. Is this a horizontal or is it a vertical ellipse? It's horizontal, which means that when I am plotting my vertices, my y value is going to stay the same, isn't it? I'm going to stay on the 0 for my y value. So all I have to do is add and subtract which value for my center x? A, right? So I know I'm subtracting it from the x value since it's horizontal. So I'm going to add and subtract my a value, which was 4, from that point 5 in order to get my vertices. So I'm going to get 5 plus 4 is 9, 0, and 5 minus 4 is 1, 0. And then we'll plot them. Whoa. Okay. 1, 0, and what did I say?
9, 0.
All right. And then I also needed to list out my foci, right? So my foci are still going to be on that same axis. So again, they're going to be keeping the same x and y value, but this time what am I adding and subtracting for my x value? This time I'm adding and subtracting my c value, which will be 2. So this time I'm going to go 5 plus 2 is 7, 0, and 5 minus 2 is 3, 0. That's my foci. And then I'm kind of done doing that part, right? So then plot that. It just happened this time to fall right smack dab in between, but that's not always going to happen. So don't think that the foci are always halfway. It's not true. Wouldn't that be nice? Okay, now I'm ready to start drawing the ellipse, except for I need to know how high to go. How do I know how high to go? B, which is going to be, it's easier to look at the square root of 12, right? What two values is the square root of 12 going to be between? 3 and 4, between the square root of 9 and 16, right? So that's really all I need for you guys to be doing is plotting that in between the correct integers at least, right? I don't care how close to one axis you are. If you want to think through that, that's fine. But as long as you're in between the correct two integers, that's really all I'm looking for. So this is a pretty fat ellipse, right? It's kind of almost close to a circle, but it's not quite a circle, right? Any questions on how we drew that ellipse? Yeah.
No, I just.
Oh.
How did you got your foci by adding and subtracting C?
Yeah. Okay. Ready? Was that a no just because you didn't want to move on, or a no because you actually need me to stay on the slide? Yeah.
Figure out how to go up and down.
That was the b value.
Oh, okay.
Okay. So this guy has a little bit more work, right?
Yeah.
What do you have to do to get this in the correct form?
Subtract 49.
Subtract 49. Sure, we can start there. What else are you going to have to do? You're going to have to complete the square. So let's kind of set that up at the same time. Okay? So I'm going to group my x's together, and I'm also going to pull out, when I complete the square, can I have a coefficient on my squared term? So I'm going to have to pull that out, right? So here I'm looking at 9x squared plus, and then how many times does 9 go into 54? 6. So what do I have to add here?
Yeah, that's
9, okay? Plus, group your y's. What do I have to pull out of the y? So 4, and then I'll have y squared minus 2y. So what do I have to add? 1. And then we said we were going to subtract the 49, but what do I also have to do when I complete the square? Add what? Yeah, good job. So remember that whatever number is, I thought I was going to get you guys there. Good job. Whatever number's out front, technically you have added 81, right? And technically you have added 4. So really I need to be adding 85. Very good. I know. Go for it. That's fine by me. All right. Are there any questions about that completing the square? Okay. So this leaves me with 9 times x plus 3 squared. And then plus 4 times y 1 squared equals... Hold on. Yeah, 36 sounds right. Okay. So now what do I have to do?
Divide by 36.
Divide by 36. Very good. All right, so 9 goes into 36. And then 34 goes into 36. Dun, 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 dun. All right. So that wasn't too bad, was it? Not so bad. All right. So A equals 3. Is it vertical or horizontal?
Vertical.
Yep, so I'm just going to draw this little line to remind myself that it's going to be a vertical. Why is it vertical?
Underneath the y.
Big number under the y, right. And then A is square root of big number, right? So then B is square root of other number. You can kind of do this next part in your head. I don't really need to see it. So when you're finding C, you're going to be taking the square root of big denominator minus small denominator, right? A squared minus B squared, which is going to be 5, but then you have to square root it, right? Does everyone? So if you're not comfortable with that, write it out. Just write C squared equals A squared minus B squared. Fill it all in. You'll get there. I'm just saying I don't really have to see that. As long as you get the correct C value, fine. If you don't get the correct C value, then you'll be losing points. All right. Where is your center? Which one? -3, +1. Since it's vertical, which variable am I changing for the vertices and the foci? I'm going to be changing the y values. Yep. Because you're moving up or down for those, right? So I'm actually just going to kind of circle that so that I remember this is the one that I'm adding or subtracting from, right? So then when I do my vertices, which value am I adding or subtracting to that? A, which is 3. So if I take 1 and I add 3, I'm up at +4. If I take 1 and I subtract 3, then I'm at, okay? For the foci, same thing, but what am I adding and subtracting? C, square root of 5, right? So you're just literally going to write 1 plus the square root of 5, right? Not too bad. And 1 minus the square root of, not 3, 5. So if you don't get a perfect number, that's fine. You'll just write it like that and then guesstimate what your numbers are between, right? So let's start plotting this stuff. I said my center was at -3, 1. And then my vertices were at -3, 4, and -2. My foci were a distance of square root of 5 away from the center, right? Square root of 5 is in between 2 and 3, right? So I'm going to be putting my foci in between, in between a distance of 2 and 3 away from the center. And then how do I know how wide to make this thing? Your B value. Yep, so you're going to go out 2 in either direction from your center, and then connect all of the outer points, right? And we're done. Yes. Okay, not with class, no. What time do we get out? Okay. All right. We want to now write some equations. So write an equation of an ellipse satisfying the given conditions. Based on where you see your vertices. So if I'm going to just kind of draw a quick sketch of this. Oops, hold on. If I'm going to draw a quick sketch of this thing, I've got a point at, whoops, not there. +6 and -6 on the y-axis, right? 0, -6, and +6. So based on where those points are, is this a vertical or a horizontal ellipse? Vertical, because my foci are vertical, right? Or not my foci, well, they will be too, but my vertices are. Okay, can you tell me what your A value is already then? What is it? 6. Yep, from the center, where's your center? Yep, that's pretty nice, right? So already, I know if I'm plugging into x squared over plus y squared over, right? Because I have a 0, 0 center, so I don't have to add or subtract anything from those. Which value am I putting that A value under? Which variable? Y. The y, because I want it to be vertical, so I want my A value under the y. Do I put 6 under y? What do you put? Square it, right? 36. All right, now I told you your foci are at 4 and -4. Does that give you that B value? No. Not directly. Or, I'm sorry, yeah, that gives you your C value is 4, and then you can find your B value by plugging into Yep. So I can plug in C squared is going to be 16. A squared is going to be, so then rearranging this, I have B squared equals 36 minus 16 is 20. Yep. Do I need to find B? Or I'm looking ultimately, what am I looking for?
B squared.
B squared. So you don't really need to go through the work to simplify that, right? Because I'm looking for B squared, this is B squared. That's going to go right there. And I'm done. Ta-da! So things you need to know for the equation. A and B and center. Right? A and B to go underneath your fractions, A squared, B squared, and then you would need to know your center to see if you're adding or subtracting anything, but then this should always be 1. Capiche? Let's try another. So this time I've given you your foci in the length of the major axis. So be careful with that length of the major axis one. So first of all, your foci I have given you is at 1 and -2, and then 1 and 4. So I have given you another vertical ellipse, right? Can you tell me where the center is based on that?
Yeah.
1, 1, right? There's a distance of 6 between those. So the center should be 3 in from either point, right? So already, how can I start setting this up? X, yeah? -1 squared, plus, and then I'll have something over that, right? And then y minus 1, because both of them have a center at 1, 1, right? Okay. Now I need to find A and B. Now I told you the length of the major axis is 10. That's a lie. Oh wait, no, that's not a lie. The length of the major axis is 10. So for some reason I thought that I had plotted the vertices. What does that mean? A is not 10. A is 5, right? Half of the length of the major axis, right? Come on, let me plot it. All right. So if A is 5, then what do I put in where? 25, square it, under the y because I want it to be vertical, right? And then it's actually really similar to what we did on the last problem to find B, right? What do you know your C value is? 3, based on where the foci were, right? And then you're just doing A squared, whoops, I lied. C squared equals A squared minus B squared. But C squared is going to be 9. A squared is going to be 25. So B squared is going to be 16 for B squared. B will be 4, but again, I'm putting in the B squared value underneath, right? And we're done again. Ta-da! No. Almost everything. Last thing, eccentricity.
Wait, is this the last slide?
An example after this last slide. Only one. What?
Because you forget by the time you put it in.
Why would I start with it? It's the last, it's an application. Okay, so the eccentricity of an ellipse is basically, so it's represented by the letter E. Okay, it is not, okay, we're going to ignore that. I forgot. They're going to start going off for the next like 5 minutes, so it's fine. I didn't get them all last time, so somebody put alarm clocks in my ceiling. But I'll get them in a little bit, guys, but let me finish these last 2 slides. Just somebody put alarm clocks in my ceiling, that's all. A weekend. It happened on Friday, and I got some of them. I didn't get others. Okay. C over A, right? C over A. I'm going to let you guys just copy that since you're not listening to me.
Come on.
Do you know who it was?
Not yet. I'm guessing it's somebody in the math department, and I had to miss lunch last week, so I didn't get to ask. But it has to be somebody with keys to have gotten in my room. It was who? No, it was probably somebody from the department. All right.
How many were there originally?
I only got 3, so it sounds like there's probably 4 more. All right. Some things to talk about. C over A. So remember, C is the distance out to the foci, A is the distance out to the vertex, right? So if the foci is really, really close to the vertex, right, then you're going to have a value that's really, really close to 1. So like this, right? And if you have 2 values like that that are really close together, when you do your C squared equals A squared minus B squared and you start solving for that, when you end up doing C squared minus, or A squared minus C squared to find B, you have 2 numbers really close, so it's going to have a really small value, right? So that's why you get an ellipse that's really flat in that case, because your B value will end up shrinking down. If, on the other hand, you have an eccentricity that is close to 0, that means that your C value is really far away from your A value, right? And what happens again is if you do C squared minus A squared to B, or A squared minus C squared to find B squared, now you have a bigger difference between the two, so B is going to end up being bigger, so you're going to get a wider ellipse. Got it?
Does that just tell you what to look for, or is that like actually a value on the ellipse?
That's, it just tells you about the shape of the ellipse. Yeah, it's not going to be something that you're going to plot. But let's really quickly just do a quick example with it. So you want to find an ellipse with vertices at negative 3, 0, and 3, 0, and then with an eccentricity of 7/10. So if you have vertices at negative 3, 0, and 3, 0, can you tell me where your center is right off the bat? 0, 0, because it's perfectly symmetrical. What distance is 3? Which value is that going to be? A. Distance from the center out to the vertices, right? Is 3. Now, some of you guys are looking at this E value, and you were like, oh, well, E is equal to C over A. So A should be 10 and C should be 7. Is that the case? No. So remember that the eccentricity is always just going to be like a simplified fraction of it or something like that, right? So really what I want to do is say my eccentricity is 7 over 10, and I know that that should be C over A, right? But what do you know that A is? So now can you find C? Yes. So you have 21/10 is C, or 2.1, right? When you know C, can you find B? Yeah, and actually it would probably be better for me to write this as a fraction then. So I'm going to keep it as 21/10. So now when I find B, you do your C squared equals A squared minus B squared. That means that B squared is going to equal whatever A squared is, which is minus whatever C squared is, which is I don't really know. I'm going to make up a number right now. It's going to be near, I think I'm close when I say that. Does anyone have a calculator on hand? I'm just trying to get through this so that we can do this. Did I get it? Haha. All right. So right now I'm just forcing a common denominator, right? What's 900 minus 441? 59.
Oh, math whiz. Beat you, crazy.
Okay. That's B squared, right?
Oh, square that, crazy.
But we don't need to because I'm just trying to find an equation. So I'm going to be plugging in B squared anyway. So when I plug this in, I've got x squared plus y squared equals 1 over. Is this a vertical or a horizontal based on where the vertices are? Horizontal because you've got your points going out horizontally, right? So I'm putting my a squared value, which is 9, underneath the x. And then I'm putting that b squared value, we don't like decimals and fractions. So actually, the way that I like to write it, if you got that far, I'd be okay with it. I like to write this as plus, first of all, 100 y squared over 459. So multiply by the reciprocal instead. I like that better, but, you know, either way. Questions on that? Homework? So we'll have about 15 minutes tomorrow for homework review. I'll teach 8.3. It has a lot of really similar things to what we just did today. It'll just be for hyperbolas instead. What? It's not on yet, but I'll get it on.